lesson 9.4, page 506, solving quadratics by completing the square. In this lesson, you will learn how to complete the square for expressions of the form x squared plus bx. You'll learn how to solve quadratic equations by completing the square. You'll find and use maximum and minimum values, and you'll solve real-life problems by completing the square. So the first thing, what is this thing called completing a square? For an expression of this form, now you notice this is standard form, x squared plus bx, there isn't any c value. You could add a constant c to the expression so that x squared plus bx plus c is a perfect square trinomial. Now let's review a perfect square trinomial. It's from lesson 7.7. That's where you learn this. Perfect square trinomials are trinomials that, remember, they had a couple key characteristics. I'm going to highlight them. The first term's a perfect square. The last term is a perfect square. And remember, the first term, the square root of that would be x. And for the last term, the square root of 16 is 4. And remember, if I take 4 times x and double it, I get the middle. That's called a perfect square trinomial. We can add a constant to these to create a perfect square trinomial. That process is called completing the square. So to complete the square, what you need to do is follow these 3 steps, and I would definitely write these in your notes. Here's the first step. Take the b value, which I'll underline, whatever this number is, and find half of it. So in other words, divide b by 2. Then, after you divide b by 2, square that number, and then take that, whatever you get, and add it to the end of this, make that your c value, and you've completed the square. So after you square b divided by 2, take that number and add it to the end of the statement, and that would be completing the square, and you'll have a perfect square trinomial. It's probably going to be easier for me just to do some examples with you, and I'm going to walk through these steps. Let's look at example A. Do you notice how b is 6? So if I take step 1, take b and divide it by 2, I get 3. Step 2, take 3 and square it, I get 9. And step 3, just add 9 at the end, and you just created a perfect square trinomial. Okay? Now let's factor it. X is the square root of x squared. 3 is the square root of 9. And do you notice if you take 3 times x is 3x and double, you get the middle? So I can factor that into that, okay, which is what you see right there. Let's go to b. Let's complete the square here. All right. If I take negative 9 and divide by 2, I get negative 4.5. If I take negative 4.5 and square it, I get positive 20.25. Okay, that's a perfect square trinomial. So if I factor this, the square root of x squared is x. The square root of this is 4.5. And if I multiply those together and double, I get 9 in the middle. Put a minus sign because there's a minus here. And there's the proper factoring for that. Now the book, they use a fractional amount. They use 9 halves. I just put 4.5. It's the same thing. Okay? That process, these 3 steps are completing the square. Why don't you pause the video and you complete the squares for questions 1, 2, and 3, and then factor your perfect square trinomial. Go ahead and do that. And I'm back, and here are the answers. I left 3 in decimal versus fraction. If you put it as a fraction, that's fine too. If you did not get these when you come to class tomorrow, make sure you ask. Now, why did we have to learn this technique called completing the square? Now, do you remember in the last lesson it was really easy to use square roots to solve problems? But you could only use that technique if there's no b value. The complete the square technique is important because we can use this technique to use square roots to solve equations that do have a b value. So if you like using square roots to solve a problem, If it has a b value, if you can complete the square, you can use the square root method. Okay? So to solve a quadratic by completing the square, you must write the equation in the form they have x squared plus bx equals d. Here's what that means. So if you want to complete squares to solve problems that have a b value, it means get all the variables on the left, but put your constant on the right first. Always make sure, if you're going to complete a square, that a is 1 before attempting to complete the square. Remember, the a value, let me highlight here, the a value is the number in front of the square term. Like you see in this problem, a would be 1. Always want to make sure a is 1 before trying to complete a square. So let's look through these two example problems here. So this first example, they wrote the problem down. Do you notice how the variables are on the left and we have our constant on the right? So now we want to complete the square. So let me take my highlighter out. B, you notice, is negative 16. So if I take negative 16 and divide by 2, I get negative 8. And then if I take negative 8 and I square it, I get 64. So I'm going to write this on paper here. We are adding 64 to the left, and we're adding 64 to the right. Now, negative 15 plus 64 is 49. Now, over here, this is a perfect square trinomial. The square root of x squared is x. The square root of 64 is 8, and 8 times x doubled would be 16x. Now, there's a minus here, so we'll use a subtraction. That's why they have this here. Now, once you get to here, this is just like problems that we did in yesterday's assignment. You can now use square roots to solve. Square root the left side, square root the right side. So square root cancels square. X minus 8 would equal plus or minus 7. So x minus 8 would equal 7, and x minus 8 would equal negative 7. So I could add 8. One answer should be positive 15, which you see here, and then I can add 8 to my second equation, and my second answer would be positive 1, which you see there. Okay? So if we know how to complete a square, we can solve problems with a b value using square roots. Let's look at this other example. Do you notice how a is not 1? The first thing we should do in this problem, well, I guess there's two things we could do. What I would do is I would divide both sides by 2 right away. I want to make sure a is 1. So let me do that. So if I divide everything by 2 here, I get x squared plus 10x minus 4 equals 0. Then I'll add 4 to each side. So x squared plus 10x equals 4, which you see that agrees with the book. Now I got to complete the square. Take b, which is 10, divide by 2, that gives me 5, and square 5. If I add 25 here, I complete the square. Now don't forget, if you add 25 on the left, you got to do the same thing on the right or your scale's not balanced. Over here, that's a perfect square trinomial. It's x plus 5 squared. And over here I get 29. Now I can square root each side. X plus 5 would equal plus or minus the square root of 29. Let me put that in my calculator. That's about 5.39, about, plus or minus. So now x plus 5 would equal 5.39 about. I'll put about. And my other equation, I'll put it over here. X plus 5 would be about negative 5.39. So if I take away 5 from each side here, I'm going to get about negative 10.39, which you see is one of the answers. And if I take away 5 here, x is about 0.39, which you see there. Okay? So we can use completing the square to solve problems with a b value using square roots. Why don't you pause the video and you try 4, 5, and 6 and make sure that you can solve these by completing the square. Round your answers to the nearest hundredth if necessary. And I showed complete work here for 4, 5, and 6. Again, as you check your work and you check to see if you got these right, if you are not getting these, make sure when you come to class tomorrow you ask, and if we can go through these step by step on the board to make sure you're following along and why I'm doing what I'm doing here on each step. Now, the book is going to use completing squares to find minimum and maximum values. I'm not going to worry about this. I think this is just creating more work than we need to worry about right now. If we want to find a minimum or maximum value, it's easy. You need to find the vertex. Use your axis of symmetry formula and find the vertex. Okay? So, for example, if we were doing example 4, find the minimum value. Let's just review real quick. Do you notice how A is positive 1? That means I know the parabola opens up, it's going to have a minimum. So I'll use the axis of symmetry formula, the opposite of B over 2A. So the axis of symmetry is negative 2. So I know X is negative 2. So just go ahead and plug in negative 2 for X, and you find out Y is negative 5. There's your minimum value. I don't think we need to complete squares for that. I think it's just extra work that we don't need right now. So if they ask you to find the minimum or maximum value, they're asking you to find the vertex. Use your axis of symmetry formula and find the vertex. So when you do the homework questions and they ask you to do this, just use those steps and you have it. So just go ahead and practice that real quick. Try 8 and 9. Make sure that you can find the minimum or maximum value for these. And I'm back, and I used the axis of symmetry formula for each, found the vertex, and then I got, in each case here, since A was positive, these are both minimums. Again, if you are not getting these, make sure you ask in class tomorrow. You'll be asked also to interpret forms of quadratic equations. What we mean by that is the following. Like if you look at this question, which of the functions could, okay, that's the key word, could be represented by this graph? Well, let's inspect each one, okay? So this first function's in vertex form. So remember, inside backwards, so the vertex for this would be negative 4, 8, which means my parabola would have a vertex here. There's no way this can be that picture. The vertex is here, this vertex isn't. So I know the first function can't be this graph. Let's go to the second one. This is in vertex form. The vertex is 5 right, 9 up. Okay, this could be 5, 9. And A is opening down. So yeah, G of X could, I'll put a little check mark, it could be that picture. Okay, let's go to the third one. I know M of X, this one can't be that picture because look at A. A is positive, which means we have a parabola opening up. This parabola opens down. So I know M of X could not be that picture. And let's go to the final one. This parabola opens down, this one does, and its intercepts are positive 2, positive 8. I guess it's possible that that could be positive 2 and that could be positive 8. So P of X could be this picture also. G of X and P of X could definitely be the picture shown. You'll be asked in this section to use what we're learning here on real-life questions. The function y equals negative 16x squared plus 96x represents the height in feet of a model rocket x seconds after it's launched. So part A, find the maximum height, and part B, find and interpret the axis of symmetry. So they're asking me really, actually for both these questions, if I find the vertex, I can answer both these questions. So that's easy enough. Find the axis of symmetry. Okay? So negative b over 2a, negative 96 over negative 32. So that would give me 3 for x. And if I plug in 3, I find out that this works out to 144. So let's answer both questions. The height of the rocket would have to be 144 feet. They show me it right there. And what does the 3 mean? Well, x represents seconds. So what this is saying, after 3 seconds, the rocket was 144 feet in the air. Pause the video and try 10, 11, and 12. 10 and 11 are asking you to determine if these could be the picture here. And number 12, they want you to find what the maximum height and time, same question here, find the maximum height and time of the rocket for that function. And here are the answers. For number 10, this picture can't be 10 because A is positive. 11, this could be the picture because 5 and 20 are positive x-intercepts and it's opening down. And there's my work to get the vertex and the seconds and height of the rocket for number 12. And to finish up, again, solving real-life problems, we could have to complete a square to do that. You decide to use a chalkboard to create a chalkboard or chalkboard paint to create a chalkboard on the door. You want the chalkboard to cover 6 square feet and have a uniform border. So we want the area to be 6, and I want this space to have a uniform width around it. Okay, same width, uniform. So you notice this length, I'm marking it, should be it should be the same amount, so I'm labeling it as x all the way around. So the length of this thing, if the entire door is 7 feet, if I take away the x on top and the x on the bottom, if I take away 2x, that's the length of the chalkboard. And the width, if the width of the door is 3 feet, if I take away x on the left and x on the right, if I take away 2x, there's my width. And remember, length times width is area. That's why they're getting the equation here. Length times width is area. So now what we do is they're going to double distribute. Okay? They'll keep the variables on one side, get the constant on the other, so they took away 21 from each side. They divided everything by 4 because if we're going to complete a square, remember, A can't be 4, it's got to be 1, so they divided everything by 4. Now they're going to complete the square. They took negative 5 divided by 2 and squared it. They kept it in fractional form. They added 25/4 to each side. Okay, I can complete the square now. X minus 5 halves squared equals 5 halves. They square root each side, and so x minus 5 halves equaled plus or minus the square root of 5 halves. And then remember, so we have x minus 5 halves equals positive square root 5 halves, and x minus 5 halves equals negative square root 5 halves. And then they just added that 5 halves. 5 halves is 2.5, by the way. They added that to each side. Okay, I'm just showing my work here. And that's why they got the 2 answers we have here. Okay, now we got to quickly check, could I have a width of 4 feet? That's not possible. The door is only 3 feet wide in the first place. So this is not a real answer. This would be correct. The door could be about 9/10 of a foot, the border I should say, could be 9/10 of a foot wide. Now they put a little trick in this problem. You got to be careful. This is the right answer, okay, but they want it in inches. So to convert, take the 0.9, multiply by 12, because there's 12 inches in a foot. The border should be about 11 inches. I'm going to stop the video here. If you have questions, make sure you ask in class.